Your Prerna Didi or Prerna Akka will tell you how you can become an astrophysicist.
Good morning. It feels really excited to actually hear your questions. I wish I was thinking like you guys when I was in my school, because then I think I would have been better astrophysicist today. So Professor Mora motivated you about astrophysics, what all we do, some great exotic astrophysics that we try to learn. What I'm going to talk about now is how to become astrophysics, and I'll concentrate on India because we should know, while being in India, what are the facilities we have, what are the institutes, and what are we really doing in India. So I thought I'll start with this slide. Who is an astrophysicist? A lot of people think this is what I do, and I assure you that I don't do that. And what my friends think I do, what my mom thinks I do, what I think I do, but what I really do is actually basically coding or running pipelines. But we do this also because this is what we are observing. So we definitely don't do the number one. But let's move to who is an astrophysicist. In a way, we all are astrophysicists because we all have wondered when we looked at the sky as a child. So basically, someone with the curiosity to learn about objects that we see in the sky is an astrophysicist. But there are only a few from all of us who take this curiosity to another level, that we use the fundamentals of science, mathematics, and also we use technology to understand the universe. So in a way, if you are curious enough to do this, then you are actually living like an astrophysicist. So Professor Mora told you about pulsars, gravitational waves. Yes, that's one part of it. But we also study sun and solar system. That is different planets that we have in solar system. And we observe sun, we observe stars. We try to study how these stars are evolving from the beginning of the universe. We also study galaxies and how galaxies are evolving with time. And as Professor Mora told you, most of the galaxies have a supermassive black hole at the center. We also study black holes. So this is a pretty image. How many of you have seen this image? Great. So can anyone tell me which telescope? No. That's not the answer, but I think, yes, I will not tell you the answer. Okay. So we also study neutron star, which you just learned about in great detail. And there are also something called exoplanets. Can someone tell me what is exoplanet? Yes. Outside the? Our solar system. You are close. She deserves the chocolate. Okay. So, and we also study large-scale structures. That is, when we zoom out from, let's say, many, many galaxies, how would the universe look like? So this is actually not a real image. Obviously, we can't just go out so much from our galaxy. This is a simulation of the universe that astrophysicists have come up with using the fundamentals of physics. So this is basically what we study, and of course, gravitational waves. I will not go into that because you have already learned a lot about that. So we study these different kind of objects in the universe, but how do we study them? We study them by observing them using telescopes, but these telescopes are not just the telescopes in optical wavelength, that is the visible wavelength in which our eyes see the universe. So this is the small region of electromagnetic spectrum that's called visible wavelength, in which our eyes see the universe, but there is much more than that. There is gamma ray, there is X-ray, there is ultraviolet, infrared, microwaves, and radio. We have all these kind of wavelengths, and the difference in them is the size of the wavelength. So the wavelength goes all the way from very small nanometer range to a meter, almost the size of me, or maybe more than that. So we have to observe the universe in all these wavelengths. Hence, we call it multi-wavelength astronomy. And this idea of different wavelengths is not really very alien idea to us. We know that we use radio in telecommunication. We use microwaves in ovens to heat our food. We use infrared for military applications, ultraviolet in our water purifiers, X-rays in medical applications, and gamma ray, that's a joke, making incredible hulks. Don't expose yourself with gamma rays. So let's look at this beautiful crab nebula, which Professor Mora was also talking about. And she already gave you a lot of background, so I'm happy with that. But if we look at this nebula in radio, infrared, visible light, ultraviolet, X-rays, gamma rays, it looks very, very different. And it gives different physics about the same system to us. For example, infrared is going to tell you about the dust that is around this crab nebula. And radio is going to tell you a lot about how the electrons are accelerating around this. And X-ray is going to tell you about how the matter is accreting onto this pulsar, which is at the center. And gamma ray is also something to tell you about very high energies that are being emitted by this system. So this is to basically motivate you that if we want to understand any object that we are seeing in the sky in a proper way, we have to look at it in different wavelengths. And now we have gone not just from, we have gone from multi-wavelength to multi-messenger in the sense that we not just observe them through this telescope, we also observe systems with our gravitational waves detectors like LIGO, which Professor Mora was talking about. So I told you that we need to observe different systems with multi-wavelength. Now I would tell you a little bit about different telescopes that we have in India. So this is the Venu Bapu telescope that's in Tamil Nadu. It's a telescope which is a facility of IIA Bangalore. I'll tell you more about IIA a bit later. So this is a telescope of size of having a diameter of 2.3 meters. It's huge. So you can add me up above, and that's the size of the telescope. And this is when this telescope was, when it started, it was actually the biggest optical telescope in Asia. And another one, which is also IIA facility, this is in Ladakh. It's a beautiful place. I never got the chance to go there, but I hope I'll go one day, and you all should try to go there. And because the sky is very beautiful there, and it's called Indian Astronomical Observatory. This is also optical infrared telescope in Ladakh. Another one is Mount Abu Observatory. That's a facility of PRL. I'll tell you about PRL also. This is 1.2 meter telescope, again in infrared optical. And then there is Udaipur Solar Observatory, which is totally dedicated to observe sun, to understand the phenomena going on in the sun. And that's also a facility by PRL. Now I showed you a little bit of optical infrared telescopes that we have in India. The biggest optical telescope that we have in India is actually 3.6 meter, and that's in Nainital. And that's a beautiful place to go. I have been there and I've seen this telescope, and it's huge, and you will actually feel amazed to see this. And this is a facility of Aries. That's also an institute. I'll tell you more about it. And also, giant meter wave radio telescope. It's very close to our heart. Most of the people sitting here, including me, observe from this telescope. This is a radio telescope, which Professor Mora was also talking about. It's a facility of NCRA. I'll tell you what NCRA also. So this telescope is observing in radio. This is not optical infrared. And it's actually a world-class facility. In the sense that we get, this facility gets proposal from all across the world, from astronomers all across the world put their proposal in this that we want to observe from this telescope. And another one is in Kodaikanal. This is also a facility of IIA. This observatory is totally dedicated to Solar Observatory. And the interesting part of this telescope is that this leads us back to actually 18th century. And when Madras Observatory was started by East India Company before India got independence. And then eventually this Madras Observatory was moved to Kodaikanal, and it's still working. And solar physicists who basically study the sun, they have 11 or more than 11 years of data from this. And I had gone there, and there's a library there, and I was amazed to see there were catalogs of 1780s. So that was really amazing to see. And then we also have Ooty Radio Telescope. This is also a facility of NCRA, which is currently not very operational, but this is also a radio telescope. And there are many more, but these are the major ones that we have. So I told you optical, infrared, and also radio. Let's move to X-rays and gamma rays. Now, on Earth, we do receive optical light. We also receive radio light and some of the infrared light, but we do not receive X-ray or gamma ray. Can someone tell me why? Yes, great. Please give him chocolate. And so, hence, if we want to observe the universe in X-ray and gamma ray, we have to go up in the sky, up in space. So this is a facility. This is a space telescope called AstroSat. This was, I think, launched in 2015. And this is a facility of ISRO. Basically, ISRO launched this telescope up in the sky, but it was a collaboration of many institutes across India who developed this instrument. It observes in X-ray, UV, that's ultraviolet, and optical. And this is basically, the life of this telescope was around 7 years, so it just ended in 2022. So it was a facility which was together developed by TFR, IUCAA, IA, and ISRO. I'll tell you about this institute in more detail. And there is also a planned mission called Aditya L1. This is going to be a dedicated facility to observe sun, but in the space. So this is going to observe the sun in ultraviolet and also X-ray. So now we know that we actually have many facilities in India. We have optical, infrared, radio, X-ray, and many more telescopes in India. But what next? India is going to participate, it's actually also helping in developing a telescope called 30-meter telescope. When I say 30 meter, it actually means that the diameter of this telescope is going to be 30 meters. It's going to be huge. And right now it's not there. This is actually just an artistic picture. So IIA, which is, I'll tell you about IIA Institute in Bangalore, that is helping to polish the mirrors of this particular telescope. And hopefully it will be installed in Hawaii. Another one, which is going to come, is a space mission called Daksha. This mission will help to observe the sky in X-ray and gamma ray. So there are very exotic objects in the sky called gamma ray bursts. We don't know what exactly they are. Some people say that, there is one evidence that it might be an event which is caused just after the two neutron star, just collide. And but we need to understand such events better. So to do that, India is proposing that we should launch Daksha mission in space, and they're going to do that with the help of ISRO. And there are going to be many more, of course. You also heard about Indian pulsar timing array that we are working on, and we hope to detect nanohertz, very low frequency gravitational waves. And there are many more planned facilities. So this is to basically motivate you that there is a lot that's going on within India and in collaboration with other countries. So there's a lot to do in future, and we are going to have better and better facility in future. There'll be a lot of data, and if you are interested in astrophysics, there is a lot of work for you to do. Now, how to become an astrophysicist, what we really have done in our life. So if I talk about the academic journey, we usually, if you look at our CV, you'll see that many of us have done Bachelor of Science or BTech, which is the technical degree. So that's undergraduate. And then we have done master course. That's either Master of Science in Physics and Mathematics or also a technical course. And then most of us have done a dedicated PhD degree in astronomy and astrophysics where we dedicate our whole time on research. Most of the institutes in India do teach you for the first year of PhD, and after that you totally dedicate your time on doing the research, data analysis, learn about universe, do whatever you want. And whichever field of exoplanet or galaxies or stars or whatever you want to study, you can do that. After that, there's also a little bit of research experience required. Now, to get that experience, you do something called postdoctorate. Postdoctorate means basically after the doctoral degree, which is the PhD degree. During this period, you gain more and more experience in research. And to tell you that I'm at this particular stage in my academic journey. And finally, you become a professor. Hopefully, all of us will come to that. So Professor Mora is also a professor, and there are many more like Manjari and others who are sitting here. And professors work with many students. They work with postdocs, and that helps them to work on many, many projects, also collaborate with different scientists. And students will basically learn from them, work with them. Most of the time it's actually learning both ways. So that's the overall idea of what we really do in our academic journey. Let's come to institutes in India. I was taking a couple of names, IAA, TFR, and this and that. So let's learn which are these institutes who are dedicated to do research in astronomy and astrophysics. Not all of them have the dedicated not the whole institute will be dedicated to astronomy, but some of them will have a particular department which is doing specific research in astronomy and astrophysics. So let's start with TFR Mumbai. I started with this because I'm working here, so sorry for the biasness. So this is Tata Institute of Fundamental Research in Mumbai. This was founded by Dr. Homi Bhabha. Who has heard about Homi Bhabha? What is he famous for? Great. Okay, so TFR has many departments: theoretical physics, chemistry, biology, mathematics. It's actually very popular for mathematics too. And there's another department called Department of Astronomy and Astrophysics. That's where I'm working right now. I am going to put the website link on my slides. If you want, I can also give you the link of my slides. So you should definitely go through the websites of all these institutes and read about it, read about the departments, etc., etc. So in TFR, okay, before I go through that, there's a beautiful building, and this is a picture which actually I took. This is the panoramic view of TFR, and you'll see there is skyline of Mumbai. Can you see that? So actually TFR is at the seashore. Like, it's very beautiful. So I took this picture from the top of one of the building. I was just, I think, standing right there at this flagpole. So other than that, so coming to the point, so Department of Astronomy and Astrophysics work on variety of things, going from infrared, optical, X-ray, gamma ray, gravitational wave astronomy, and as I told you about the AstroSat mission, TFR had played instrumental part in developing one of the instrument in AstroSat. There is a study on sun, star formation, exoplanets, etc., etc., and theoretical astrophysics. So for the student, there are two programs in TFR. One is called Integrated PhD, which is basically master plus PhD course, and also PhD program, which is after the master's course. And this very interesting visiting students research program, which you can do when you are doing your master or also undergrad. So you should definitely go through the website and look at all these opportunities. So one can do master's course, PhD course, and also visiting student research project in TFR. coming to another institute, that's NCRA, National Center for Radio Astrophysics, that's in Pune. And the facility which I was talking about, GMRT, very close to your heart, is actually the facility of NCRA, TFR. And this institute is basically dedicated to radio astronomy. So in radio, obviously pulsars. Now you know that we observe pulsars in radio. And also we observe radio galaxies, sun, study about galaxy formation and more. I told you about GMRT. And NCR is also very much into developing the instrumentation, you know. The facility, GMRT, it took years to come to this particular stage. And all the instrumentation, everything is being handled by NCRA. So NCRA also very much like TFR, because NCRA is also part of TFR. It's basically a Pune campus of TFR. Also has PhD and integrated PhD program, very much like the Mumbai campus, and also the visiting student research program. So please go through the website and learn more about it. Let's come to another institute in Pune. It's called Inter-University Center for Astronomy and Astrophysics, in short, IUCA. IUCA works on a variety of things. People there work on gravitational waves, learning about magnetic fields in universe, large-scale structure, high-energy astrophysics, also instrumentation. And there is a joint Pune University, SPPU stands for Savitribai Phule Pune University, and IUCA MSc Physics, Astrophysics program that's coming up. And it's very new, I just learned about it yesterday actually from Sanjit. So they are going to have this MSc program along with PhD program that they already have. There is a lot of outreach that IUCA does. There's also visiting student program. So there's a lot going on in this institute. Also, you should go through the website and learn about it. And actually, if you look at the campus of this institute, you'll see that there are these statues standing there. Can you see that? So that's actually Einstein. So they have made and there's also Newton sitting and apple is falling from the tree. So it's a beautiful campus. So now let's come to IIA, which I was talking about. So just to let you know, I did my PhD from IIA Bangalore. And this institute actually have observing facility, 4 of them. That's one in Kodaikanal Solar Observatory I was talking about. Another one is Kavalur, which I told you that Venubappu Observatory, where there is 2.3 meter optical telescope. When it was installed, it was biggest in Asia at that time. There is also one in Gauri Badnoor, that's a radio telescope actually. And that's observing facility that's handled by our IIA and also another institute called RRI, which I'll tell you about. So IIA does mainly optical and infrared study of the universe, and also a little bit of X-ray and radio astronomy, and star formation. There's actually a very dedicated group which works on sun, because we have the access to Kodaikanal data of sun of many, many years, which I told you about. And so there are basically 2 programs in IIA. One is integrated MTech PhD program, where you basically work on instrumentation. So by instrumentation, I mean that developing of the telescope. So it's not that you have to actually just do BSc. If you have done a BTech in electronics, let's say, or mechanical engineering or something like that, even then you can apply for this integrated MTech PhD program in IIA, where if you are interested to develop telescopes, different kind of telescopes, their detectors and various parts of the telescopes, you get to do that while doing your master's, that's MTech, and also your PhD. Other than that, there is a single PhD program also, which I was doing. So that's not the integrated program, that's just the PhD program, where you can work on anything you like. And as many others, there is visiting student program for undergraduate also, and also for master students. So do go through these websites and look at that. Okay, so who can tell me? Great. You people are too intelligent. Okay. So Sir C.V. Raman, he won a Nobel Prize in physics in 1930. And when he won a Nobel Prize, at that time, he was the first one from Asia to win a Nobel Prize in science, not just physics, in science. And Do you know what, for what he won the Nobel Prize? Great. Okay, so Sir C.V. Raman, he established this institute called Raman Research Institute in Bangalore. And this institute actually not just work on astrophysics or astronomy, they have a department for astronomy and astrophysics, but they do work on variety of things like theoretical physics and many other. I'll just talk about astronomy and astrophysics group. They are involved in instrumentation also, the development of radio telescopes and many other things, observational astronomy, theoretical astrophysics also, and they also have PhD program and visiting student program. And the campus is really beautiful. This building is very, very beautiful building. You should go there. So at this stage, if you want to go, I'm not sure if they're really open. Sometimes they are open for outreach and all, but as an undergraduate or a master student, you can definitely apply for visiting student programs to any of these institutes. Let's come to another one. It's a very, very great institute, Indian Institute of Science. And Indian Institute of Science has many, many courses and variety of subjects, mathematics, computer science, and chemistry, biology, I don't know what all. So it's actually ranked 1 university in 2022 as per NIRF, Ministry of Education. And they also have an astronomy and astrophysics group. And IISc actually came up with this program called JAP. It's called Joint Astronomy Program. And I think it was established in 1980s. It's very old. And currently, the astrophysics that we have in India, actually some of the directors of these institutes they were doing their PhD in the JAP program. So the program is great because it's not just limited to IISc. If you're doing your PhD through the JAP program, you can join any of the institute, RRI, IAA, even ISRO. So JAP astronomy program is great. I think one of our colleague is JAP student, and right now he's doing his coursework, first year of PhD. And most of the time I learn from him. And so they also work in a variety of things, gravitation, galaxies, solar physics, large-scale structures. And there's a lot of fundamental theoretical physics group there. They are very much interested in doing theory. And the campus is really beautiful. Maybe Avinash can tell you about it more. So there is another institute in Bangalore itself called ICTS, International Center for Theoretical Sciences. That's also a center of TFR. They also have variety of research groups, and one of them is Astrophysical Relativity Group. They are very much interested, dedicated to gravitational waves. And when gravitational waves were detected for the first time, can someone tell me when it was detected? 2015, actually. So scientists working in this group were actually involved in that discovery. So they do the study of early universe, gravitational waves, etc., etc. They also have two kind of programs, integrated program, master PhD and PhD, in physical sciences, not just astronomy. So you enroll for physical sciences in general. That's actually part of, physical sciences basically has mathematical, chemistry, physics, everything. But after getting into the institute, you can choose any of the department that you like. One of them is Astrophysical Relativity Group. Let's move back to North India. So there is a dedicated astronomy institute in Nainital. It's called Aryabhatta Research Institute of Observational Sciences, ARIES. And I was telling you about this huge telescope, right? That's a facility of ARIES. It's a 3.6 meter telescope. DOT actually stands for Devsthal Optical Telescope. So they actually not just work on astronomy and astrophysics, they also study atmospheric sciences, the study of the atmosphere on Earth. And they also work in developing the telescope, instrumentation, etc. They have a very nice visiting student program and PhD program. And they also have MTech PhD that is, again, involved in the development of telescopes. So you can really see there are too many, we are doing astronomy everywhere, north, south, east, west, everywhere. So let's come to Ahmedabad. I was telling you about PRL, Physical Research Laboratory. They also have astronomy an astrophysics division, and they have two of the facility. One is dedicated to solar physics. That facility is in Udaipur, this one. And then they also have 1.2 meter telescope at Mount Abu. And they do multi-wavelength astronomy. They do a variety of things, star galaxies, pulsars, sun, etc., etc. Also instrumentation, and they have the PhD program. So now you have learned more or less about many of the institutes. Let's come to another one. That's in South, Thiruvananthapuram. Indian Institute of Space Science and Technology, that's IIST, and I hear that they have a very good master course in astronomy and astrophysics. It's a dedicated course in the first year itself where you get to have many, many courses in astronomy and astrophysics. So that happens in Department of Earth and Space Sciences, and they also have a PhD program. Sorry, I forgot to put the website link here. I covered many of the institutes now. There are many IITs, so I couldn't cover them. But all of us know that there are Indian Institute of Technologies, IITs, and you can see there are many of them in India, going all the way from Jodhpur, Kanpur, Indore, Hyderabad, Goa, and Bombay, Delhi, Gandhinagar, etc., etc. All of them, obviously, they are dedicated to physics, but some of them also are doing astronomy and astrophysics. For example, in Indore recently, in IIT Indore, they started an astronomy and astrophysics dedicated group, but all of the IITs in their physics department do have scientists working on astronomy and astrophysics. Some of them are actually here. Shantanu, he's in IIT Hyderabad. And there are also ISERs. They are also very good institutes for undergraduates. Indian Institute of Science, Education and Research, and obviously IMSC that does a lot of mathematics, great mathematics and physics. And in the physics department, some of the researchers are working on astronomy, like Manjari. And then there are also NICERs, National Institute of Science, Education and Research. These NICERs are also having nice undergrad and master courses. So all of these which I just listed here, IITs, ISERs, NICER, IMSC, and many other universities in India, they all have undergrad, master, PhD programs. Now, let's move to the painful part. If you want to get into these institutes, what do? So there are various entrance exams that I just wanted to list them here. Not all of us know about these exams. Even I didn't know when I was in school which exam to give, which not to give. So I thought I'll list some of them here. So if you want to get into undergraduate, there is an exam called Common University Entrance Exam that happens around July or September, something like that, CUET. Through this exam, you can, if you clear that, you can get into undergraduate programs of many universities. And there is also an exam which is conducted by ISC Bangalore called Kishore Vaigyanik Prosthahan Yojana exam that happens in May, and called KVPY. If you clear this exam, you actually get fellowship during undergraduate, during your undergraduate. About the master entrance, once you have finished your undergraduate course, for the master, the exam that you have to clear, or you should clear, are GATE, that's Graduate Aptitude Test in Engineering. So actually also an exam that you clear to get into BTech, that you might know of. And also JAM. There's also IIT JEE, most of you know. IIT JEE rank, if you get some rank, that can also be used to get into, let's say, ISC or some of the universities. It's not just for IITs. So another exam for masters is called JAM, Joint Admission Test for Masters. This is specifically for IITs. So if you want to do masters in IITs, you should clear this exam. That happens around February. And many of the universities in India, they also have their individual entrance exams. So you should check that also. Now, let's say you have finished your masters. If you want to do PhD, what are different exams? So let's say you want to get to TFR. You want to work in TFR, NCRA, ICTS, or Mumbai campus. The exam that TFR conducts is TFR Graduate School exam. That happens in December. If you clear that, you can give interview in any of the campus of TFR, going all the way from NCRA, Mumbai and ICTS and many others. IUCA in Pune also conducts their IUCA National Admission Test, INET. That's also for masters and also for PhD program. IAA also have their individual program, individual test called IAA screening test. If you clear that, you can get into either PhD program or MTech PhD program. And there are also common exams, as in if you clear any of these exams like JEST, NET, or GATE exam, you can apply to any of the institutes in India. So that's easy, because let's say you have cleared JEST, you can actually apply to any of the institutes. And it's not just that you'll get in, you have to give interview also to get PhD, to get into the PhD program. So all of these institutes, they conduct their individual interviews based on your undergraduate and master courses. So whatever you have learned, physics, mathematics, and many things that you have learned in your undergraduate, masters, based on that, your interview will happen. And hopefully you'll clear and you get into PhD. You must be wondering, there's so many exams, there's so many institutes, so many telescopes. What should I really do? So, well, at this stage, you need not really do a lot. All you need to do is study your basic physics, get the concepts clear, mathematics, also computer science. Computer science helps because, as I told you in my first slides, what we really do is coding. And to do that, you need to learn programming languages, like you might have heard about Python, C++, and many others. So don't worry so much about it right now, but I'm telling you that learning these languages help. And you can learn it eventually. If you have computer course right now, great. If you don't have, that's okay. You will get to learn it in your undergraduate master courses. Doing a project in any of these institutes during your undergraduate or master course, it helps. But it's not really necessary. So you need not really get into that and forget about your studies during undergraduate. You should not do that. The first priority should always be doing basic physics, learning mathematics, learning the basic concepts. And most importantly, you should enjoy science. You should also question it. And I wish I was questioning like you guys before. So in my title, I had also written life as an astrophysicist. I would say it's unique. It's unique because the whole universe is our laboratory. Most of the other field of science, I'm not degrading any of them, they're great. But the idea is you have a lab where you're working, like maybe your chemistry or physics labs. But for us, lab is the whole universe. And we are actually sitting inside the lab. Like, you know, in biology lab, they dissect the frog. It's like frog looking at the lab and learning about the lab. So we are like that. So the whole universe is our laboratory. And we are connecting small to very large. So Professor Mora was talking about, you know, timing the pulsars at nanoseconds. Such a small number. And then we are talking about galaxies, large-scale structures. So we are connecting everything from small to large. So it's about all the kind of scales that we have, also in time and space, everything. So in that manner, we are very unique. And I would like to quote Dr. T. Prabhu, who is our colleague from INPTA. He was telling this yesterday, that astrophysics is actually queen of science, because everything merged together in astrophysics. If you have done, let's say, BTech in electronics, BTech in mechanical, or anything, computer science, you still can do a lot in astrophysics. And like developing telescope. And if you have done physics, great, that really helps. Mathematics, great, you can do theoretical astrophysics. And so it's connecting everything. In astrophysics, we also, some of the scientists are also using the concept of biology. There's something called astrobiology also. They are basically studying various molecules in the very big clouds that they see in Milky Way galaxies, etc., etc. So there is use of every physics or chemistry or mathematics, computer science, technology, everything merged together. So in that sense, Prabhu was saying that it's really a queen of science. And towards the end, I would like to show you some pictures of pioneer astrophysicists who were in India. So Professor S. Chandrasekhar, who knows about Professor S. Chandrasekhar? Can you tell me about him? Yes? For? Great. So he won the Nobel Prize in around 1980s or so for studying the stellar evolution of galaxies and all. And this is Professor Meghnad Saha. He's very important for astrophysics because he gave something called Saha ionization equation. Saha ionization equation connects the temperature of the star, the density of the star, and what we call something called spectra of the star. From the spectra, we can get to know what kind of molecules, what kind of atoms are there, and what should be the temperature of the star. All that can be done using the Saha ionization equation. So this equation is really important to learn more about star evolution, galaxy evolution, etc. And our favorite also, Professor Govind Swarup, he was instrumental in developing the GMRT telescope. And as I told you, it's a world-class facility. And he was pushing so hard to get to this observatory, ready for us. And there's a lot of science that is happening right now. Very recently, I heard that there was furthest galaxy was observed using GMRT. It was very, very far away using GMRT in radio. So I would like to end with this. Thank you. I hope you learned about institutes and many things that we're doing in India.
So there are also institutes in Kolkata. I mean, many. I think SN Bose, where I think Pratik graduated. I think ISI.
Sorry, I missed some of them. Yeah.
Yeah, and
also
SAR
SINP.
Institute. Yeah, and also universities. Also, many universities do.
Yeah, I mentioned universities because I couldn't quote all of them. Yeah.
And I think private institutes also now, like BITS. All the 3 BITS institutes are involved in astrophysicists, and also some other telescopes. Also, there are also cosmic ray and gamma ray TV gamma ray telescopes. Just wanted to add.
Yeah. Thank you.
Good morning, ma'am. Hope you're doing good.
Thanks.
I'm Neha from KVHVF.
Hello.
Ma'am, actually, how long will it actually take to become an astrophysicist or astronomer?
Great question. We are asking ourselves. Well, it does take long, but it doesn't matter so much because we are enjoying it, right?
Okay.
Particular to astrophysics, obviously you know PhD takes around 4 to 5 years, 5 years usually in India, and masters also 2 years, undergraduate usually 3 years, and but postdoc it varies. I mean, it's not a course. Postdoc position is a experience position where you are just gaining experience. You are just enjoying science. So that if you do like 3 to 4 years or something like that, or some people actually get permanent position, become professor after PhD also, who are great. But now you can add up. So, yeah.
Okay. Ma'am, also, are the procedures same for becoming an astronomer?
Yeah. So the main difference in astronomer and astrophysics is basically astronomer we say who are more dedicated to observing. Astrophysicist is more of theory also. Nowadays everyone is doing everything, so there is not really a difference there. So,
Okay. Ma'am, last question.
Yeah.
Is it a stressful job?
I think every job is stressful job, but it's not really a job. If you are enjoying something, it's not a job for you. So we are doing this because we are enjoying it. So stress can be from anything. Stressful, you have many sources of stresses in life. So not really, I would say.
Okay, ma'am. Thank you.
Good morning, ma'am. Ma'am, usually the parents say that the courses like astrophysics and all have not, no scope. They say like that there is no scope for this, like getting a job. It is not possible. Ma'am, why do they say like that?
You can maybe show them these 2 of these talks that there is a lot of scope that we just talked about, and maybe they don't know about it, I would say. They don't know, and many of us didn't know. I mean, I was doing my undergraduate, I didn't know about these institutes. So since we don't know, we feel like that. But once we know about it, we learn about that so many things that we are doing, and we get to learn so much about the universe. I don't think that statement really is true.
I'd also quickly like to add to both of the people who just asked questions that even though the education is long, you do start earning in your PhDs. So after after a master's degree, when you get into a PhD program, you do start earning. So it's not like you're just educating yourself for 6 years plus.
Nowadays, you are getting fellowships in masters, and I
Yeah.
told you about one of the entrance exam of IISc, right? Yeah. If you clear that, you get fellowship during undergraduate also. So you're earning from the beginning.
There's a very strong misconception that after astrophysics there are no scopes. So I'll give a somewhat long answer because students ask me these questions also. So so first of all, I mean, with knowledge of physics and astronomy, right, there are lots of practical applications. GPS, which you use in a Ola, Uber, airplanes, that doesn't work without principles of relativity, which you study while you become an astrophysicist. The World Wide Web, I think you gave URLs, right? That was first invented in a physics laboratory by someone with a physics training, okay? Wi-Fi, okay, because of which I can check my internet and this thing, that was spin-off of research in a radio astronomy lab, okay? So these are some examples, and many statistical and data analysis techniques which you learn, so I know like many people with do a PhD in astrophysics and all, they learn computational techniques. One technique which they use, Markov chain Monte Carlo, MCMC, it's used a lot in finance. Okay, it's used in, I think, it's used in industry also a lot. And many of them who, let's say, I mean, they decide not to continue astrophysics, but they take with them their knowledge of whatever statistics and things which they learn in MCMC, and many other things also, how to solve differential equations, how to use clusters and all that, how to use computing and all that. Some things you would not learn if you were doing astrophysics, or even if you're doing computer science, like none of my CS faculty know MCMC, only those who have taken my course in physics, only they know how to use MCMCs. So certain skills you can only learn while if you study to become an astrophysicist. So I think when your relative or someone says it has no practical application, it's just so not true.
And that's where I was saying that it's everything merged when we are doing astrophysics. Many of these techniques to developing, developing techniques to developing instruments to many other things, astrophysics is really the queen of science.
Okay, so let us thank Prerna once more.